Hello everyone, I am Aditya from Shivaji Science Junior College.
Myself, Pandit from Pandit Bacharaj Vyas.
So today we are working in the ATL Tinkering Lab. From the past 3 months, we have been working on a really innovative project of a pseudo-satellite. What a pseudo-satellite actually is. We all know that space agencies launch satellites for different dimensions of users. We use satellites for communication, for imaging, for data of weather conditions, for collection of geographical data, as well as many other aspects. We use satellites for communication, for network providing, etc. But they all know satellites cost a lot. They need a lot of capital infrastructure like rockets, launch pads, base stations, and etc. They also need a large amount of fuel, which is also costly. This all procedure of launching a satellite is really capital intensive, and they really need a change. Here today we have come up with a really innovative idea which will be totally transforming the space sector. Today we have come up with a pseudo satellite. What a pseudo satellite does is it works on 100% solar energy. The solar cells fit in the solar pseudo satellite power the whole satellite. It is also capable of giving services like network providing, surveillance over a definite area, aerial surveillance, collection of weather data, analyzing different aspects of navigation, providing navigational services are all the functions of a pseudo satellite. Let us take a look how our pseudo satellite looks. So here we can see the functioning of an ultrasonic sensor. The ultrasonic sensor here is used for radar imaging. We all know that radars are used for tracking of targets all around a flying object. So here the ultrasonic sensor is working as a radar. In powerful pseudo satellites which will be manufactured in the future, we will be using advanced radars which will image all the flying objects in an airspace. Here we have the GPS module. The GPS module is used for location or for showing latitudes and longitudes of an area. We use it to map all the conditions of an area. Here we get the longitude and latitude data from the GPS module. We can also see this in this screen. So as I have shown earlier, we have completed with the radar stage. We have figured out the camera part. We have also done programming the GSM. Now what we need is we need to have a data about the 3 dimensions achieved by the GPS module. The GPS module is one of the most core technologies in this project, and so it's very important that we know everything about it. So here we have the latitude and longitude which we already figured out that day, but today the third factor too has been figured out, and it is the altitude in meters. So this is the altitude right now on which we are working. So as I raised the GPS module, we can here see a variation in the height. As I lowered the GPS module, the altitude decreased, and it continued to decrease as I decreased the height, and so it is decreasing. Now we can also see the speed card, what speed it is carrying. Since we are static right now, it is showing a 0.02 speed, 0.17 speed, which is negligible. So we can see that here we have the date for it. We have the date on which the data is being received, the time at which the data has been recorded. We can see that the data has been recorded in seconds. Every 1 second we are getting a reading. So here we can see the time 10:11. So there's a gap of 1 second, after which data has been collected. We also have char rx, the receiving part, and this is a bit technical part which doesn't seem to have any importance for common people, but this is an important part too. And here we have the distance scorecard. Since we are at this coordinate, there is no distance we have covered, so it's right now the same. We can see that there is no variation in it. It is 318.38 only, since we haven't changed our location and we are static, but as we change our location the distance will be shown. So this is the way it works. On auto scroll we can see that every 1 second the data is being added. So that is how it works. Key functions why this pseudo satellite is mind blowing is that the functioning of a GSM module. So this is a GSM module. A Raspberry Pi has been used as a central computer in this pseudo satellite. We are using this advanced computer for analyzing all the data we are collecting through our sensors. This Raspberry Pi would be analyzing all the data being connected from the sensors. So this is an ESP32 camera which is being used in this pseudo satellite for imaging purposes. This ESP32 camera has a range of about 100 meters. With extended technology and high class modules, we can extend its range to lot more of kilometers. So this ESP32 camera will be used for imaging purposes. Here we have an Arduino Uno which will be used to collect all the data from the sensor. This Arduino Uno would be receiving the data from all the GPS module, the ultrasonic sensor, the camera, the GSM module, and in this way the Arduino would be sending the data to the Raspberry Pi, which will be in return analyzing the data and thus again sending it to GSM, and then the GSM would be sending the data collected on SMS over the required user. In this way the pseudo satellite is a futuristic idea and will really transform the space sector. This pseudo satellite project will really be able to change the way space sector thinks.